So children, before we begin with worksheet 1, let us quickly recall back all the concepts. Sir Isaac Newton proposed 3 fundamental laws of motion. The first law states that a body at rest remains at rest and a body in motion continues to move in uniform motion in a straight line unless an unbalanced force acts on it. This law explains inertia, which is of 3 types. Inertia at rest, tendency to stay at rest. Inertia of motion, tendency to continue moving, and inertia of direction, tendency to continue the same direction. Well, Newton's second law states that the rate of change of momentum is directly proportional to the net external force applied and acts in the direction of force. So this force F is given by F is equals to the rate of change of momentum, that means delta P by delta T. Change in momentum can also be written as final momentum minus initial momentum, that is Pf minus Pi by T. And we know that the momentum is defined as the product of mass into velocity. Okay, so final momentum means mass into final velocity minus initial momentum means mass into initial velocity upon time. If you take out m as common, then you are left with v minus u upon t, or the rate of change of velocity v minus u by t can also be written as acceleration. Hence F is equals to ma. Okay, so children, from this above equation we can also add that this F can also be written as mv minus mu upon t. Bringing the t other side, ft is equals to mv minus mu, and this, the product of force and time, is called as your impulsive force. Well, the Newton's third law states that for every action there is an equal and opposite reaction. Okay, well children, we have also discussed with inertial and non-inertial frames. Coming to inertial frame, the frame of reference in which Newton's laws holds good is called as inertial frames. In simple, non-accelerating frames are called as inertial frame of references. For example, if we consider a train moving with constant velocity, and if we toss a ball straight upwards, it falls back into our hands. Whereas in non-inertial frames, all accelerating and rotating frame of references are called as your non-inertial frame of references. For example, if the same train starts accelerating suddenly, the ball appears to fall backwards. If the same train accelerates suddenly in forward direction, the ball falls backwards. This is an example of a non-inertial frame of reference because here the frame is accelerating. Children, but always remember that Newton's first law is the criteria to identify the inertial frames. That means if Newton's first law is valid, means no doubt it is an inertial frame of reference. Is that clear, children? Well, and also remember that to make Newton's laws holds good in non-inertial frames, we need to introduce the concept of pseudo forces. Well, so based on the above concept, let us try to understand and solve few numericals. Moving to the worksheet 1, the first question. The behavior of a body under zero resultant force is given by which behavior of a body under zero resultant force. So zero resultant force means force is 0. If F is equals to 0, then this implies that the mass into acceleration is 0. This implies that mass into acceleration can be written as v minus u by t equals to 0. And this will holds good only when this mass can never be 0. That means v minus u by t must be 0, or v minus u equals to 0, or v must be equals to u. That means the body must move with the same constant velocity or the same constant speed in a straight line now. Okay, suppose if u happens to be 0, then this implies v is also 0. This statement indicates that a body at rest continues to be in the same state of rest. Okay, whereas v equals to u implies that a body in motion moving with uniform speed continues to be moving with uniform speed. So this statement is according to the Newton's first law. Okay, a body at rest remains at rest, whereas a body with moving with uniform speed continues to move with uniform speed in a straight line. Hence, our correct option must be option number 1, that is first law of motion. Moving to the next question, which law of Newton defines an inertial frame of reference? Just now we have discussed that Newton's first law is the criterion to identify inertial frame of reference. Hence, answer is first option, that is first law of motion. Moving to the next question, the statement acceleration is 0 if and only if the net force is 0 is valid in yes, of course it is in inertial frame of reference. In non-inertial frame of reference, bodies are accelerating. All accelerating and rotating frames are taken as non-inertial frames. Whereas, so non-accelerating frames, non-accelerating means no acceleration, 0 accelerations are valid in inertial frame of references. So the statement acceleration is 0 acceleration. Okay, it's nothing but your inertial frames. Next, you move forward when your car suddenly comes to a halt and you are thrown backward when your car rapidly accelerates. Which law of Newton's is involved in these cases? Yes, children. So this is nothing but it is all according to the law of inertia. Okay, the first law itself is called as your law of inertia. Okay, inertia at rest, inertia of motion and inertia of direction. So if we move forward, your car suddenly comes halt because you have the tendency to move forward, but the car as suddenly stops. Halts means you will be in a tendency to move forward according to the law of inertia of motion. Okay, you are thrown backward when your car suddenly rapidly accelerates. So the position whenever the car suddenly accelerates in the forward direction, you have the tendency to be in that particular position. When the car begins forward, you are not able to cope up with the situation and as a result you will fall backwards. So because of the tendency of a body according to the law of inertia, so law of inertia means also nothing but your first law of motion. Hence the third answer, that is first law. Okay, well, moving to the next question, you are thrown outer side when your car suddenly takes a turn. Which law of Newton is involved in this? Of course, Newton's first law. It is all according to the inertia of direction. Now the direction is changing, so answer is Newton's first law. Okay, well, moving to the next question, an object is thrown vertically upwards with some velocity. Object is thrown vertically upwards with some velocity. If gravity is turned off at that instant, the object reaches the maximum height. What happens? So the object continues to move in a straight line. The object will be at rest. Yes, of course, the object will at rest. An object is thrown vertically upwards with some velocity if no gravity is there. Let us see. Suppose if the ball is moving forward, any object if it is been moving upward, then as long as it moves upwards, its velocity decreases. And finally, after attaining certain height, that is maximum height, at maximum height the velocity of the object is 0. Okay, so now when it reaches the maximum height, it attains 0 velocity. Okay, so now what happens? The gravity is being seized off. The gravity is being removed off. Then what happens to the body? It stays ahead there itself because of no velocity. Okay, so 0 velocity. So body stops. That is body at rest condition. Okay, so the object will be at rest. Well, suppose if the gravity acts means the body will come downward. Which of the following is the most significant law of motion given by the Newton? The most significant law given by Newton is Newton's second law. Newton's third law only just correlates the action-reaction pairs. That's it. So there is nothing more about Newton's third law we need to discuss. Coming to the Newton's first law and second law, we can define Newton's first law with respect to Newton's second law. So as we have discussed earlier, that F is equals to ma. Suppose if a is equals to 0, this implies v can be equals to u. So if u is equals to 0, this implies v is also equals to 0. A body at rest continues to be in its state of rest, and a body moving in motion continues to move with uniform speed in a straight line unless it is acted upon by an external force. That means no force means these are the conditions possible. So we can define Newton's first law with respect to Newton's second law. Hence the major thing is the Newton's second law of motion. So with respect to Newton's second law of motion, we can also define Newton's first law. So this is the most significant law. Okay children, now moving to the next question, question number 8. The quantity of motion of a body is best represented by its linear momentum. See, mass, we can't do anything with respect to mass. Okay, speed or only velocity can do nothing. But linear momentum, so with respect to time, if you measure the linear momentum, you can define the motion of the body, the force acting, whether it is at rest condition, moving condition, accelerating condition, everything can be defined if you're good at knowing the condition for linear momentum. Next question. Well, a certain particle undergoes erratic motion. So some motion, okay, at every point in its motion, the direction of the particle's momentum is always in what direction, children? Is same as the direction of its velocity, same as the direction of its acceleration. So which one is the condition, children? The same as the direction of its velocity. Just now we have discussed something regarding the momentum. Momentum is nothing but mass into velocity. So the direction of the particle's momentum is always same as the direction of velocity. Well, moving to the next question, question number 10. Inside a railway car, a plumb bob is suspended. You know, railway car or cab, if you observe that something, a plumb ball is being there, okay. And a helium filled balloon is tied by a string to the floor of the car. So for the same car, okay, wheels, let us suppose, okay, a helium balloon is also being attached. Yes, this is filled with helium, okay, lightweight air, and this is a bob. A bob is being hanging from the roof of the cab. So this is what is being given. Inside a railway car, a plumb bob is suspended from the roof and a helium-filled balloon is tied by a string to the floor of the car. When the railway car accelerates to the right side, some direction it is been moving, okay, the railway car accelerates towards the right. Then what happens? Then both the plumb bob and balloon move to the left? No. Both the plumb bob and balloon will move to the right? No. Plumb bob moves to the left and balloon moves to the right. Exactly. This is what was true. Okay. So that means a cab is there, and if it is, suppose if it is moving towards the left side, then what happens? If the cab moves to the left side, the ball must, because of the pseudo force, what I say is the cab itself moving to the forward direction, then the bob will be moving in the backward direction due to the pseudo force. But whereas the helium force will be only affected due to the motion of the body. That means the helium ball will move in the same direction as the direction of the car, whereas the bob will move in the opposite direction to the motion of the car because of the pseudo force that is acting. So plumb bob moves as the car is moving towards the right side. Where is it given, children? Car is accelerating towards the right direction. The bob must move towards the left, whereas the balloon must move towards the right direction. Okay. Well, so moving to the next question, children. Question number 11. N balls each of mass m impinge elastically in each second. So every second how many balls are falling, children? They are falling, m number of balls are falling, but how are they falling? Elastically. Elastically means after falling again they are reflecting back. So this is the condition. Okay. In each second on a surface with velocity u. What velocity? U velocity. Okay. They fall with u velocity and again they come back with the same u velocity. The average force experienced by the surface you are asked to find out. Children, generally you know the formula for force as mass into acceleration, isn't it? Force is defined as mass into acceleration. So this is our general notation. So now the same force F can be written as, in order to find the average force. So what mass? This is not a single ball. There are n number of balls are falling for every second. So we need to take the total mass. What is that? Total mass into acceleration can be defined as the rate of change of velocity. That means change in velocity upon time. Change in velocity upon time. Is that clear, children? Well, so this can be written as the total mass. What is the total mass, children? Mass of each ball is m. So total mass is, how many such balls are there? N. So n times of m into change in velocity. So velocity change. Generally we give this change in velocity as, okay, I'll write it here. Change in velocity. It is given as final velocity minus initial velocity. I'll write it like this. Vf minus Vi. That's it. Change in velocity is given by final velocity minus initial velocity, where initial velocity they gave it as u. Initial velocity they gave it as u. They reflect back with the same velocity. That means final velocity must be u in the opposite direction. This will be minus u. Hence, the change in velocity instead of Vf minus Vi, we can replace with is Vf means minus u. This minus and initial velocity means again u. Therefore, final velocity minus initial velocity can be written as minus 2u. How is it given, children? Vf minus Vi, that is can be given as minus 2u. So that is the rough part I have tried explaining you. So this can be written as minus 2u. Is that clear, children? Well, upon time, change in velocity, numerator we take it as minus 2u upon time, and this is falling at every second. Every second means time is taken as 1 second. So this can be written as minus 2mnu. That's it. So average force is given as minus 2mnu. Okay. The magnitude of average force now can be given as magnitude of minus 2mnu. Simply it is nothing but 2mnu, and hence your correct option must be option number 2, that is 2mnu. Okay. Well, moving to the next question. A ball reaches a racket, you know, you play shuttle and all, okay, rackets, okay, tennis, table tennis. A ball reaches a racket at 60 meters per second along positive x direction. It's also similar to the previous problem, okay. So speed of the ball is now given as 60 meters per second along positive x direction and leaves the racket in the opposite direction with the same speed, similar to the previous problem. Assuming that the mass of the ball is 50 grams, easiest system it is given, and the contact time is 0.02 seconds, the force exerted by the racket on the ball is, here speed is given as 60 meters per second, options in Newton, so SI system, but here mass is given as 50 grams, so CGS system. You need to convert it into SI system. Well, based on the given data, we are asked to find the force exerted by the racket on the ball. Okay, so what is given data, children? Speed, initial speed is given as u, itself is given as Let us write down the given data. Initial speed UI is given as 60 meter per second. Direction is positive x-axis, and leaves the racket in the opposite direction with the same speed. That is final velocity. Initial velocity, velocity initial and velocity final. Same speed 60 meter per second in the opposite direction, that is minus 60 meter per second. Mass of the ball is given as 50 grams. So 50 grams can also be written as 50 into 10 power minus 3 kg converted. Well, and the time is given as 0.02 seconds. So these are the given conditions. You're asked to find the force. So substituting those values, we may get the result as force F is equals to mass into acceleration or mass into final velocity minus initial velocity upon time, isn't it? So F can be written as mass is how much, children? 50 into 10 power minus 3 into final velocity is taken as minus 60 meter per second, and this minus symbol, I write it here. VI initial speed is given as again 60 meter per second whole upon T, time is given as 0.02 seconds. Hence we can write the value of F as 50 into 10 power minus 3 into minus 60 can be written as minus 120 upon this 0.02 can be written as 2 into 10 power minus 2. Is that clear, children? Well, after further simplification, how much are you getting? So let us simplify this. So F can be equals to this 10 power minus 3 and 0. I'll rearrange the terms, children. This can be written as 50 into minus, I'll put forward everywhere, minus is there, minus 50 into 120 into this 10 power minus 2, if it is carried upward means it will become 10 square. This 10 power minus 2 I brought up whole upon this 2 in denominator, and 10 power minus 3 bring it downwards. This will become 10 power 3. Clear? So 10 power square means it can is nothing but 100. 10 square can also be written as 100, and 10 cube can also be written as 10 cube can be written as 1000. So this is how I am writing it. Is that all clear, children? Well, so after further simplification, how much you are getting? These 3 zeros will get cancelled, and this 2 goes 6 times. So your final answer must be 6 5s 30. So this is minus 300 newtons. What is the answer, children? This is minus 300 newtons. So your two options is that 300 Newton along positive x-axis means if it happens to be plus 300 newtons, it will be 300 newtons along positive x-axis. But here answer is minus 300 Newton. What does minus 300 indicates? Magnitude is 300, direction is opposite to the positive x-axis. That is 300 Newton along negative x direction. Hence the correct option is 300 newtons along negative x direction. Clear, children? Well,